Welcome to the STEM Digital School offered by Africa Teen Geeks. This is grade 6 in Natural Sciences and Technology. And my name is Onkarabe Desizwe. Guys, I will be your natural science and technology teacher from now on. And I am looking forward to be working with you guys. All right. So guys, just a quick chat quickly. Guys, can we please use the group chat to send through our answers, okay? And if you do have any questions, all right, don't hesitate to raise your hand, all right, using one of those icons on the participants bar, as well as, guys, if I'm going too fast, do indicate for me, all right? And if I am going too slow, please do indicate as well, all right? So guys, let us get into today's lesson. Right, so I see Michael and Jocelyn are already using the group chat. Thank you, guys. Okay, so guys, today we'll be looking at dissolving. All right, so this is part of term 2. This was covered in term 2, but it is part of term 3 in the revised ATP. Okay, so this is part of matter and materials. And what we will be looking at today is the rate of dissolving, as well as some of the factors that affect the rate of dissolving. Okay, so we are going to have a class activity. And basically what we need to learn is that the time it takes for particles to disappear. All right, so that is the rate of dissolving. Okay. Okay, so these guys, this is basically what you guys should already know by now. And firstly, it's that matter exists in 3 phases. Okay, so remember that we have a matter which is in solid phase. We also have matter which is in liquid phase, as well as matter which is in the gaseous phase. Okay, and another thing, guys, is that the arrangement of the particles differ from phase to phase. So guys, I'll be showing you guys 3 pictures right now, and I need you guys to basically just give me an educated guess as to which these arrangement refer to. Okay, so here is the first picture. So this is an arrangement of particles, all right? Does it indicate an arrangement of particles in a solid, liquid, or gas phase? You guys can use the group chat to just basically send your answers, all right? So do these particles in this picture, which is shown before you, indicate the arrangement of particles in a solid, liquid, or gaseous phase? So guys, don't be scared to send through your answers to the group chat, or if you want to raise your hand, then we can unmute your mic and you can just give through your answer. Okay, so I see Talia says it's a gas phase. Okay, so do we have any answer from anyone else? Okay, Aware 2 also says it's a gas phase, all right? Okay, so guys, let's basically just move on to the next picture, and then I'll give you guys the answer when we are done. So Jocelyn also says gas. Lebo also says it's a gas phase. Okay, thank you guys for your participation. So here is the next picture. Does it indicate arrangement of particles in a solid, liquid, or gas phase? Does it indicate the arrangement of particles in a solid, liquid, or gas phase? So I see Talia says liquid. Awetu also says liquid. Okay. Right. Thank you very much, guys, for the answers. Okay, now let us see the last picture. Okay, Lebo also says it's a liquid. Right. Thank you very much, guys. And then the third picture, does it indicate arrangement of particles in a solid, liquid, or gas phase. Okay, so I see Talia says it's a solid, all right. Lebo says it's a solid. Awaitu also says it's a solid. So I believe you guys just guessed this, or rather, you used the last man standing for this picture. All right. So guys, just to revise again. All right. So the first picture indicates the arrangement of particles in a solid. Remember, particles in a solid, they are in a fixed position and only vibrate on their fixed position. Okay, they have limited movement and they are structured. Okay, so that is why the first picture, the one with the red, is indicating the arrangement of particles in a solid. And most of you guys got it wrong and you said it's a gas. All right, so Talia is there, I think, trying to correct her answers. She says the first one is a solid, and yes, Talia, that is correct. The first picture indicates a solid. Okay, the second one is not a gas, it's a liquid. All right, so remember what we know about liquids is that they take up the space of the container. Okay, so they also have a free movement, but not as much free movement as particles in the solid, in the gas phase. All right, so the blue particles here, they are indicating the arrangement of particles in a liquid phase. Okay, and in the third picture, this is indicating particles in the gaseous phase. As you guys can see by the indication of the arrows, that the particles are freely moving everywhere. All right, so I hope everyone understands that. Okay, so remember, this is on the first topic of matter and materials. Okay, so remember, guys, you should be able to know this and be able to identify whether particles are arranged in a solid form, liquid form, or a gaseous form. So remember, solid, we said that they are fixed. Okay, they only vibrate in a fixed position. And then when we look at liquids, liquids move around, all right? They move more than solids, but less than gases. Okay, but then gases, the particles move freely. Okay. I hope everyone is following. And if there is something that you don't understand or you have a question, also please do write your question in the group chat, or you can raise your hand and you can unmute your mic. All right. Okay, so let us move on what we should already know. Okay, so what we should already know is that mixtures, right? The definition of a mixture is that two or more substances or materials that have been mixed together. So that is what we refer to as a mixture. And then we have different ways in which we can separate mixtures. And I would like to ask you guys, just give me an example of the different ways we use to separate mixtures. Different ways we use to separate mixtures. You can use the group chat or you can raise your hand, then we'll unmute your mic. The different ways we use to separate mixtures. Okay, so I see Vits user says we use our hands. All right, beautiful. So that would basically refer to hand sorting. That is beautiful. All right, is there anyone else who can give me an example of how we separate mixtures? Okay, Level, you sent an emoji. I think, is that a confused or thinking emoji? I can't see clearly, but okay. Do we have any other example as to how we separate mixtures? Just refer back to your work in matter and materials, thereby mixtures. Okay, Level, it's a confused emoji. All right, we'll clear the confusion out. Don't worry. All right, so guys, just a quick recap. All right, so remember we have mixtures, and in mixtures, we said that this is where we have two or more substances or materials which have been mixed together, and we refer to that as a mixture. For example, we can have sand and stone mixed together, right? And we can refer to that as a mixture. And if we want to separate the sand and the stone, there are different methods, right, in which we can use to basically separate sand and stone. Another example is that if you have cookies and you have coloring pencils and you mix them together in your pencil case, how will you basically separate your coloring pencils from your cookies? This user, I think, he or she said, he mentioned we using our hands. So that's an example of basically separating mixtures. So that mixture of code keys and coloring pencils, we can use our hand and sort them out. So another example that we have is also called filtering. And this is where we use filter paper. An example is where coffee beans are used. Yes, Michael, that is correct. It is hand sorting. Okay, thank you, Lebo. We move them from each other. Beautiful. So those are the different ways that we use to separate mixtures. All right. So other examples is filtration. We also have sieving, and we also have settling or decanting. All right. So remember, guys, these are the things that you guys should know. It is by mixtures on matter and materials. All right. You did this just before the lockdown, and I believe during the STEM lockdown school, we also covered this. All right. But it is no problem. If you do have any questions, just post them in the group chat and we will deal with the questions. All right. Okay. So as I have mentioned, that an example is filtration, and the noun for that is filtration. Okay. So we also looked at solutions, and we said that solutions are mixtures in which the separate particles cannot be seen. And when we're looking at solution, this is when we are dissolving a solid into a liquid or a liquid into a liquid. Okay, does that ring a bell? Is everyone following? So guys, remember, if I am going too fast, to just indicate for me, okay? Okay, so the next point is that every solution has a solvent and a solute. Okay, so the added substance that dissolves in a liquid is called the solute. Okay, so what we mean by that is that the solute is the minor component in the solution. Okay, for example, if we have a cup of water and we are adding a teaspoon of sugar, then our sugar will be what we refer to as a solid. Okay, it is the minor substance or the minor component in the solution. Okay. Right, and then the liquid that the solid dissolves in, this is what we call the solvent. So if we can just refer back to the example that I just gave you guys right now of the cup of water as well as the teaspoon of sugar, then in this case, then our water will be what we call the solvent. So the solvent is basically the major component or the major substance in our solution. Right, so that's very much important to note. Every solution has a solvent and a solute. Okay. So guys, just quick question. What is an insoluble substance? What is an insoluble substance? Because remember, we have already covered this, right? So this is just a quick recap. What is an insoluble substance? Guys, can use the group chat or you can raise your hand. What is an insoluble substance? And just another thing as well, guys, if you do not know, please also tell me that, ma'am, we do not know what an insoluble substance is. Okay, so I see Talia, your hand is up, all right? Just unmute your mic right now. Okay,
Hello.
Talia, you can speak.
An insoluble substance is a substance or solid that will dissolve even in a solvent, even after mixing.
It will dissolve.
Yes, ma'am.
Okay, thank you very much, Talia. Do we have any other question? Answer? Anyone else who wants to answer? Talia said that it's a substance that will dissolve, right? An insoluble substance is a substance that will dissolve, even in water. Does anyone have a different answer? This user says it is a substance that cannot dissolve in water. So Talia, just a quick correction there. As insoluble substance cannot dissolve in water. All right, so some of these examples include sand. So we would refer to sand as an insoluble substance because even if we pour sand in water, it will just settle down there at the bottom, right? It will not dissolve in water. All right, so Talia, insoluble substance, it is a substance that does not, all right, it does not dissolve in water. So Lebo says an example is a rock that is beautiful, Lebo. So yes, a rock wouldn't dissolve in water and we would refer to it as an insoluble substance. All right, awesome guys, beautiful. Okay, so let's move on. So this is just an example that I gave you guys about the sugar and the cup of water. So remember we said that our sugar is the solid and the water is the solvent, all right? And if we mix the two together, we call it a solution, all right? So a solution always has a solid as well as a solvent. Okay, so Talia is a substance that will not dissolve in water even if it's mixed. Beautiful, Talia. Yes. Yes, insoluble substance. It is a substance that will not dissolve in water, even if it is mixed. Thank you very much, Talia. Okay, so now, guys, now that we have covered the previous chapter's work or summarized the previous chapter's work, let us look into dissolving. Right, so this is basically what our topic for today is, right? Dissolving. Okay. So dissolving, what is dissolving? When you speak about dissolving, what do we actually entail? Right. So firstly, dissolving involves incorporating a solid into a liquid to form a solution. So if you guys just remember what I said in the beginning of the lesson, that it could be incorporating a solid into a liquid or a liquid into a liquid as well. Ne? So an example, as we have already mentioned, the first example of incorporating a solid into a liquid, that is our sugar into the water. All right. Another example would be putting milk into water. All right. So we would form a milk water solution type of thing. All right. So guys, remember, if you do have any questions or you are confused, please do send your questions on the group chat, or you can raise your hand to ask your question. Okay. Right, then the next point is that when a substance is dissolved into a liquid, it takes time for the particles to disappear completely. So these particles, they are referring to the particles of the solute, okay? And then the speed at which dissolving happens, this is what we call the rate of dissolving, all right? And then the rate of dissolving basically measures how fast a substance dissolves in a solvent to form a solution. So we can also just refer back to the example we made about our sugar teaspoon of sugar and water. So if we were to measure the rate of dissolving, we would be measuring the rate of how fast the sugar dissolves in the water. All right, so that is basically what this fourth bullet is explaining. Okay, and then now, guys, we will also investigate whether certain changes that you make affect the rate of dissolving. A change that affects the rate of an experiment is called a factor. Okay, so we'll just look in deeper detail into that in the next slides. Right, so in this topic, guys, we will learn more about fair tests as you investigate how certain factors affect the rate of dissolving. All right, so let us move on. Okay, so here we have a young lad, probably your age, guys, also a grade 6 young lad who is doing an experiment. All right. Who is doing an experiment, and I'll just read the text there. It's figure 1, and we got it from the Via Africa grade 6 natural science and technology textbook. It says, when you do a science experiment, you need to make sure that the test is fair. Right? So you carefully measure the amounts you are using and you keep as many things the same as you can. Right. Okay, so now let us look at the factors that affect the rate of dissolving. So guys, remember we said that the rate of dissolving is the speed at which the solid is disappearing in the solvent. All right. So guys, remember, if you are confused or if I am going too fast, just indicate for me. All right. So guys, temperature affects the rate of dissolving. If we're stirring or shaking the mixture, it affects the rate of dissolving, as well as the grain size of the solid affects the rate of dissolving. So today we'll only be looking at the temperature of the mixture, and then tomorrow we'll be looking at the stirring and shaking as well as grain size as to how it affects the rate of dissolving. Right, so let's get into it. So we have an experiment. So it's just quite unfortunate that, guys, we can't actually do the experiment in class, but I will just take you guys through the experiment. Right, so basically in this experiment, we are testing temperature of the mixture, how it affects the rate of dissolving. So what we will need is a 250 milliliter beaker or glass jar or plastic cup. We are also going to need a measuring cylinder. We're going to need ice cream stick. We are also going to need a 5 milliliter measuring spoon. We're going to need coarse salt or sugar, thermometer, water, a kettle, and stopwatch. So basically, this is what we'll be doing in this experiment. Let's get into it. Firstly, we're going to measure 150 milliliters of tap water, okay, and pour it into the beaker, right? And then we're going to place the beaker on a dark surface, then measure the temperature of the water. So remember, we're just going to take water from the tap and then measure the temperature of the water using the thermometer. All right, so the thermometer, it measures the temperature. Okay, then we're going to take 5 milliliters, a 5 milliliter spoon of salt. So if you don't have salt, you can also use sugar, right? And then as the next step indicates, we are going to hold the spoon above the beaker and start stirring. All right. So the moment we pour the salt, the salt or the sugar in our beaker, our neighbor or our friend will start the stopwatch, and we will basically stir the sugar or the salt in the beaker slowly. All right. So this will be done slowly with an ice cream stick. Okay. Then we're gonna keep up the same slow stirring motion, right, until the last of the salt crystals dissolve. So until we don't see any sugar or we don't see any salt, this is depending on what you are using. Okay, so guys, and then we are immediately going to stop the time, right, when this happens. And then we are going to record basically our results in the table, all right, and enter the time it took for the salt to dissolve, all right. So, and then now we are just still continuing with the experiment. Are you guys following, guys? Are you following? You are very quiet. Are you following? I see Talia says, yes, you are right, Lebo, well done. Oh, okay. All right, okay. Thank you. Okay. So guys, as we continue with the experiment, what we're going to do now, so remember we had a kettle and we also had more water. Okay, so we're gonna warm some water to a temperature between 30 degrees Celsius and 35 degrees Celsius. And we're gonna repeat steps 1 to 5 using the 150 millimeters of this water. So remember step 1, it said that we are pouring the water into the cup, and then we're going to put it into a dark surface, and then we put in our thermometer to basically measure the temperature of the water, right? So we're basically going to repeat steps 1 to 5 for the different temperatures of water. Okay, so the step also says that take care to stay at the same slow rate as before. So we are going to try to basically stay, with the same intensity. If we step slow in the first cup, even in the second cup, we'll try by all means to stay slow, all right? And then the last bullet says that we need to repeat steps 1 to 5 with water warmed to a temperature between 40 degrees Celsius and 45 degrees Celsius, and then with water warmed at a temperature between 50 degrees Celsius and 55 degrees Celsius. And it also gives us a note there which says, remember to stay at the same slow rate as before. So again, with the water, which is between 40 degrees Celsius and 45 degrees Celsius, we're gonna measure with our thermometer to basically get an accurate number, and also write down the results in our result table as to how long it took for the solid to dissolve in the water. Okay, so guys, what's important to note here is that the water, right? The waters are at different temperatures. So we have about 4 cups of water at different temperatures. Okay, so one is hotter than the other. And what we are measuring is that how will warm water affect the rate of dissolving, okay, or how will cold water affect the rate of dissolving. So as we increase the heat of the solvent, is it going to affect the rate of dissolving? So that is basically the aim, the overall aim of this experiment. Okay. Right, let us continue. Okay, so here we have a picture. It's figure A. This is also from the Via Africa textbook, and it is just showing us what we were supposed to be doing. So that is the spoon of our salt or sugar, and we're adding it to the cup, and we're using an ice cream stick to basically dissolve the salt or the sugar in our cup. And then we have a results table. So this is where we had to record our results, okay? And I have my results table here, which on the left, it is indicating the temperature of the solution. So remember the first cup that we had, it said that we need to pour water from the tap. After pouring water from the tap, we take it to a dark space, put the thermometer in the cup and measure the temperature. So it gave me 26 degrees Celsius, all right? And then we heated water, right? Obviously using our kettle or the Bunsen burner. Okay, and you were supposed to get a temperature which is between 30 degrees Celsius and 35 degrees Celsius, as well as just heat more water as well to give you a temperature between 40 degrees Celsius and 45 degrees Celsius. And we're also supposed to get water, which is ranging between 50 degrees Celsius and 55 degrees Celsius. So guys, on the right, yeah, it is indicating the time it took for the salt to dissolve. And this time is recorded in seconds. Okay, so the cup at which the water was at 26 degrees Celsius, it took 150 seconds for the salt to dissolve. And then the cup at which the water was between 30 degrees Celsius and 35 degrees Celsius, it took 100 seconds. The cup at which the water was between 40 degrees Celsius to 45 degrees Celsius, it took 45 seconds to dissolve. And the cup at which the water was between 50 degrees Celsius to 55 degrees Celsius, it took 26. Okay, so guys, I will just need you guys to basically take a memory picture of this result table, because we are going to have questions which are referring to this table. Okay. Right, here are the questions. So question 1 says, use the results in your table to draw a bar graph. Your teacher will explain to you how to do this. Use the notes below to help you. Right, so guys, do we know how to draw a bar graph? Do you guys know how to draw a bar graph? Just give me an indication. You can use the yes or no icon on participants. You can just press yes or press no, or you can type it in the group chat. Do you guys know how to draw a bar graph? Okay, let's user says yes. And everyone else? Lebo. Okay, thank you, Lebo. Now it also says yes. Okay. So I'm guessing majority of you guys know how to draw a bar graph. Right, so let's just go through basically what we were supposed to have. Temperature, remember we said that factors that affect our experiment, or other things that affect our experiment, we refer to them as a factor. Okay, so temperature is a factor in this case. And it reads as follows: the factor that you changed on purpose is called the variable. Okay, so remember guys, we changed the temperature of the water, right? So remember we had 1 cup of water which was at 26 degrees Celsius. We had another cup of water which was between 30 to 35 degrees Celsius, so on and so forth. Okay, so temperature must be on the horizontal axis. So when we talk about a horizontal axis, we're talking about an axis which moves from left to right. Okay, and then a variable that you can change on purpose is called an independent variable. So the variable that you change or that you are in control of, that is called the independent variable. Okay. And then we have the dissolving time that you measured must be on the vertical axis. So the dissolving time changed because the temperature changed. We say that the dissolving time is dependent on temperature. So dissolving time in this experiment is called the dependent variable. So this one is on the vertical axis, and remember vertical axis is up and down. All right, is that let me just show you guys here on the graph that I drew. Okay. Okay, so guys, if you can just see here, we have pink highlights on it. From 0 to that area there, this is what we refer to as the vertical axis, and our dissolving time is on this axis, and this axis is also called the, or rather it is where you find the dependent variable, okay? And then on this axis here at the bottom, where we find our temperature, this is where we find our independent variable. Okay, so guys, if you did this question or you have a Via Africa textbook and you did this exercise, your bar graph should look something like this. Okay, so every time on a graph, we always put our unit. Okay, so remember temperature, it is measured in degrees Celsius, and time is measured in seconds. Right. Okay, so guys, let's do question 2, and I am going to need answers from you. So what does this mean? Does the dissolving time increase or decrease as the water temperature goes up? So guys, just remember the results table. Yeah? Does the dissolving time increase or decrease as the water temperature goes up? Or actually, we could even use the graph to answer this question. Does the dissolving time increase or decrease as the water temperature goes up? So guys, here is the graph that should also basically just give you a heads up on answering question 2. Does the dissolving time increase or decrease as the water temperature goes up? Please send through your answers on the group chat, or you can just raise your hand and we can unmute your mic. Okay, so this user says it decreases, sea level says it increases, our two says it decreases. Right. So level, just look at the graph again. Remember, the first bar hitting the tap water, which was at 26 degrees Celsius. The second bar is indicating the water, which was between 30 to 35 degrees Celsius. And then the third one is indicating the water, which was between 40 to 45 degrees Celsius, right? Then the last one, obviously, it is the 50 to 55 degrees Celsius. Okay. So remember, we are increasing temperature. As we move into the right, we are increasing the temperature. Beautiful level. It decreases. Thank you. Right. Then question 3. If the dissolving time is shorter, does the solid dissolve at a faster or slower rate? If the dissolving time is shorter, right, does the solid dissolve at a faster or slower rate? So what does it mean if we look at, let us look at the last bar, which is at between 50 to 55 degrees Celsius, right? Does the solid, or rather, what does it basically indicate if we have, or rather, if the, excuse me guys, if the solid dissolved at 20 seconds, what does that indicate? Does it mean that it dissolved faster or slower? If the dissolving time is shorter, does this mean that the solid dissolves at a faster or slower rate? Okay, but user says faster rate, right? The level also says faster. Okay, P1 says faster, away2 also says faster. Right, beautiful guys. So guys, if the dissolving time is shorter, then it means that the solid dissolves at a faster rate. Okay, so beautiful guys, beautiful. Then we have, I think it's the last question, right? Complete the sentences below. An increase in temperature makes a solid dissolve. An increase in temperature makes a solid dissolve. Lebo says faster. Beautiful. Okay, see Mahlori's hand is up. I'll just unmute your mic now.
Hello, ma'am.
Hi.
Hi, ma'am. So should I complete the second sentence?
Yes, you can complete the second sentence, Mahlori.
Okay. So temperature is a factor that affects the rate of dissolving.
Beautiful. Thank you, Mahlori. That was beautiful. So indeed, guys, for question 4B, temperature is a factor that affects the rate of dissolving. Okay, so alternatively, we could say that it impacts the rate of dissolving. Okay, So I think we can just go here, and these are just the answers to the questions that we have been answering. Okay. So guys, just to conclude the lesson quickly, what we have learned today. So in this activity, guys, in the previous activity that we had just covered, the amount of salt and the amount of water and the slow stirring that we did were the same in all 4 tests. And these are the factors that we controlled, okay? And a fair test, guys, you should know a definition of a fair test, all right? This is a test in which you only change one factor and keep all the other factors the same. So remember in our experiment that we did just now, we changed temperature. So that was the factor that we changed, and we kept the amount of salt the same, the amount of water the same, as well as our slow stirring movement the same. Okay. Then just something to note is that the warmer the water is, the quicker the salt or sugar dissolves. All right, very important to note, guys. The warmer the water is, the quicker the salt or sugar dissolves. Therefore, an increase in temperature caused the rate of dissolving to increase. Okay, so basically, guys, from this lesson, our take-home message is that as we increase the temperature of our solvent, right, we will increase the rate of dissolving. Okay. Yeah, well, Michael, I see the 4 minutes. Okay, last point, as you increase the temperature of a liquid solvent, you give more energy to the particles of the solvent, making them move faster. And last one, a higher temperature increases the rate of dissolving. So guys, if there's anything that you've learned today, just take this 1 point home, that higher temperature increases the rate of dissolving. Okay. So guys, here we just have a beaker rather, which is just showing us how a solid dissolves faster in warm liquid in the left than in the cold one on the right. The particles of the hot solvent move faster, so they bump the particles of the solid harder and spread them around faster. Okay, so we also got this picture from the Via Africa textbook. Okay, so guys, thank you very much for joining in today's lesson. So this is the textbook that I used for this lesson. If you guys use different textbooks, just write the names of the textbooks in the group chat. Then I will also just try to utilize them in our lessons. But this is the textbook that I am using for lessons. You guys can also get yourself this textbook, all right? You can go on Snaplify to get this textbook. So I see Talia says and Vits user, they're using Platinum. All right. So I'll also just try to incorporate some Platinum activities in our lessons. Right. So guys, thank you very much for joining in the lesson. Thank you for participating. Guys, it's been awesome, and enjoy your next class, and see you guys tomorrow again. All right. Have a wonderful day, guys. Bye-bye.